In this video, I will do one example using the root test. Will be this one. Then I will do another where I will use the ratio test. And I will make another video where we use the ratio test with power series and finding the radius of convergence. But for this one, we will focus on series of numbers like this one. Now, this is, when I look at this, it's shouting at me, root test. And why is that? Well, I see something all raised to the k as my kth term. And this suggests the root test, because in the root test, what I need to calculate first of all is this, and simplify the kth root of the absolute value of ak. Well, we will see when you have something all to the k, that makes this quite nice. Okay, what is this? Well, here, this is already positive. This is positive for every k. I do not need the absolute values. This will be k squared plus 3 over 4k squared plus 5 to the k. Now, what is the kth root? And this is the beauty of the root test. The kth root raises this to the 1 over k. Now you see how nice this is, because look, power to a power, we multiply, the power will be 1. So this becomes k squared plus 3 divided by 4k squared plus 5. Okay, that's very simpler, I should say, very nice compared to the original terms, ak. Now we take a limit for the root test as k goes to infinity of the kth root, absolute value of ak, and we get a limit as k goes to infinity of k squared plus 3 over 4k squared plus 5. This limit we can calculate. You might see it immediately. If not, you can divide everything by the highest power of k that you see, which is k squared. And we get 4 plus 5 over k squared. Now, this limit is 1/4 because this term and this term, they both go to 0. My limit is 1/4, which is strictly less than 1, okay? By the root test, this series, k goes from 1 to infinity of k squared plus 3 divided by 4k squared plus 5, all to the k, converges. Okay, so this is an example of the root test. Okay, here's the other one, and I mentioned I personally am going to do the ratio test. Why do I choose the ratio test? When I see factorials, the ratio test is what I naturally think. And this one you might think, whoa, it looks complicated. It's actually quite fun, as we will see. Okay, but in order to use the ratio test, the first thing we need to simplify is the absolute value, ak plus 1 over ak. Okay, well, again, just like the last one, these are all positive, so I don't necessarily need the absolute values. Here we go. We have k plus 1 factorial, a k plus 1 squared divided by k plus 1 to the k plus 1. This is ak plus 1, but then we divide, so all over, maybe I'll put this all over, what is the kth term? Well, we see it looking at us, k factorial, k squared over k to the k. Okay, well, we invert, we multiply, then we're going to have to do some work. Okay, so for the moment, let me keep this in the numerator. Then we have this in the numerator. What else is in the numerator? We can see here, this is going to be a k to the k. Okay, then what's in my denominator? Okay, well, I have a k plus 1 to the k plus 1. Then I have a k factorial, and I have a k squared. Okay, so far so good, although trying to find a limit of that as we go to infinity, we are not ready to do yet. But some very nice things happen. What am I going to use here? Maybe I will make a little side box. We know k plus 1 factorial is k plus 1 times k factorial, and then there should be an equals here. Equals, okay? So here, if I take k plus 1 factorial divided by k factorial, I'm left in the numerator with a k plus 1. So I'm going to try to group things to make my life a little easier. This divided by this will become a k plus 1, okay? And then I have these two things that are squared, so I will write a k plus 1 over k. This is all quantity squared. It's this divided by this. Let's figure out all the terms I have used. So this one, okay? And I've used these two. Very nice. Now, here, this is to the k. I can pull off one k plus 1 and put it here. And I will be left with, I will have a k over k plus 1 to the k. Now, if you don't see that this and this are equal, pause the video, do some intermediate steps until you see it. But I have purposefully grouped it because look, now I can cancel k plus 1 and k plus 1 is 1 for every k. So in my next step, I will write this. This I can certainly, for example, take a limit as k goes to infinity. The function x squared is continuous. Bring the limit inside. We would have the limit is 1 squared. Right? This part goes to 1. Okay, just thinking ahead. Now, this other piece is kind of interesting. As it's written, it's not exactly something we have seen, but it almost is. So watch what I do next. 1 over. And then I can write this as k plus 1 over k to the k, right? Definitely this is equal, okay? And then one more step. This is k plus 1 over k squared. This is 1 over 1 plus 1 over k to the k. Now I am exactly ready to calculate this limit. This is probably one of the harder ones that we will do using the ratio test because we had to do a lot of algebra to get ourselves to this point, and we have to spot what is this limit. Well, we had this, right? This part in the denominator as k goes to infinity goes to e. 1 plus 1 over n to the n. That's how we saw it in our group work, for instance. This limit is e. So this, look, this term, if we take a limit, goes to 1, as I mentioned. This term, if we take a limit, goes to 1 over e. Both the limits exist. We take a limit as k goes to infinity, absolute value ak plus 1 over ak. This is a limit as k goes to infinity by our multiple steps of simplifying of k plus 1 over k squared times 1 over 1 plus 1 over k to the k. And this, we know if this limit exists, and if this limit exists, then the limit of the product you can multiply. So this would be 1 times 1 over e. This is 1 over e, which is less than 1. Yay, okay. So then by, what was this, ratio test, we have a conclusion. Ratio test, this series, which is k factorial, k squared divided by k to the k, converges. This was a bit challenging of one, but it was also wonderful, quite fun.